5.4. Model Evaluation and Optimization. Welcome to Module 5.4 on Model Evaluation and Optimization, where you're about to transform from a machine learning apprentice to a savvy evaluator of artificial intelligence. First up, let's chat about a confusion matrix. It's not as perplexing as it sounds, I promise. Imagine you've built a model to predict whether an email is spam or not. The confusion matrix helps you see how often your model is correct. Those are true positives and true negatives. But more importantly, it highlights the mistakes: false positives and false negatives. Why care? Because sometimes, like in medical diagnoses, a false negative could be far more serious than a false positive. Next, play with precision and recall. Precision tells us what proportion of positive identifications was actually correct, while recall tells us what proportion of actual positives was identified correctly. It's a trade-off. Chasing perfect precision could mean missing out on true positives, so you'll learn to strike a balance with the F1 score, a harmonic mean of precision and recall. Now, let's get predictive with ROC curves and AUC. ROC sounds like a mythical beast, but it's just a graph showing the performance of a classification model at all classification thresholds. The curve plots true positive rates against false positive rates, and the AUC gives you the probability that the model ranks a random positive example more highly than a random negative. We want this number as close to 1 as possible. Think of it as your model's high score in an arcade game of prediction prowess. But a model isn't much use if it only works on the data it was trained on. That's where cross-validation comes in. Imagine teaching your model to be an all-terrain vehicle of prediction, ready to handle any road it encounters. Cross-validation helps you assess how well your model will generalize to an independent dataset. You'll be doing splits, not the gymnastic kind, but dividing your data into parts, training on some, and testing on others to verify your model's robustness. And if your model's performance is subpar, don't despair. Dive into hyperparameter tuning. Think of your model like a high-performance race car. Hyperparameters are your gears and switches, and tuning is about finding the optimal settings for peak performance. Tools like GridSearch and RandomSearch will be your pit crew, methodically testing combinations to eke out that last bit of accuracy. Finally, cap off with Ensemble methods, where you'll learn that sometimes, the whole can indeed be greater than the sum of its parts. By combining multiple models, you can smooth out their individual quirks and errors to achieve better performance. Ensemble methods are like a heist team, where each member brings a unique skill to the job, covering others' weaknesses. Throughout this module, you'll not just learn, but apply these concepts in Python, using libraries like scikit-learn to practice on real datasets. You'll evaluate, iterate, and optimize, transforming theory into tangible skills. So, ready your Jupyter notebooks, and let's begin the journey to model mastery.